All right, this is section 3.6, quadratic functions. A lot of this information you've probably seen before. Some of this might be new, and then some of this we're going to kind of combine some skills that we've seen in the past in a little bit different way today. Okay, so for the first thing, just a definition. A quadratic function is just a function in the form ax squared plus bx plus c, where a, b, and c are real numbers. And then the big thing here is a can't be 0. Basically, the reason a can't be 0 is because if we had 0x squared, then that is gone. And then our function is just bx plus c, and that's just a linear function. A couple examples here. There's our 3x squared, so we know it's a quadratic. Honestly, the rest of it doesn't really matter. As long as you have your x squared, you know it's a quadratic. So there's our x squared. There's an x squared also. It's okay that the coefficient is a fraction here. All right, one of the first things we're going to focus on is something called vertex form. So you should have explored a little bit, and you should have an idea of why it's called vertex form. But we want to practice getting those equations or expressions into vertex form. Okay, we're going to complete the square. There's the directions for completing the square. We've actually done these before, and I'm going to do them just a little bit different than how we have in our notes. I'm going to more work on completing the square to solve it, and then I'm just going to move the answer to the other side like we've done in the past. Okay, so the first thing, I need to get the constant on the right side. Everything else stays on the left. We're going to factor out a GCF if there is one. In this case, there is. Now, we're only going to factor it on the left side. We can't do anything on the right. Then we're going to complete the square. So to complete the square, remember we look at that term in the middle, our b term. We take half of it, and we square it. All right, so on the left side here, we're just going to leave it as 4 squared. Now, here's one thing on the right side that you've really got to pay attention to. Okay, this step is really important. We had a negative 50. Now, a lot of times, we just would add 16 because that's 4 squared. But the difference on this one, we had this coefficient that we took out before. So the coefficient is still there, and so we need to make sure that we take in, we need to add in that coefficient to both sides. Okay. Remember, once we do this, the left side really gives itself the answer. Over here we have negative 50 plus 48, so that's just negative 2. We're going to add the 2 back to the other side. And actually, that's going to give us our answer. So I'm going to go ahead and write it in vertex form. And then we add 2. All right, so then that is in vertex form, and we'd be definitely ready to go ahead and graph it. Okay, we'll do the next example here together. This one's a little bit different because we've got this negative going on, so we just need to be careful with that. Again, I'll start by subtracting the constant. I'm going to factor out a negative 2. I'm going to look right here, chop it in half. And on this side, we leave it as 4 squared. Over here, okay, remember we've got to keep our coefficient with us. So I'm going to go negative 2. It's 4 squared again. It happens to be 16. I wasn't real original with the numbers, I guess. That's x plus 4 squared is what we're going to get when we factor that expression. And then negative 35. Let's see, minus 32 is actually negative 67. All right, and I'm going to move this 67 back to the other side, and we are in vertex form and ready to graph. All right, if you look at the top of the next page, there's 2 more examples. I'm not going to work through those in the video here. But I do have those posted to where if you want to work through those and then check your answer, you definitely may. All right, once we get to vertex form, there is tons of good information here that's going to help us. All right, so we are going to, first of all, we are going to move the graph left or right h units, and then we're going to move it up or down k units. Now, the other thing there, the vertex just shows up right there at hk. Now, I do have it sort of starred. You want to watch your signs, okay? And what we mean by watch your signs, we'll look at here in just this next example. If our a term is greater than 0, so that term out there, maybe if you factored something out, if it's greater than 0, the graph opens up, it looks like a U, and then remember this vertex, now that's called a minimum because it's at the very bottom of our graph. If a is less than 0, the graph opens down, looks like an upside down U. We've got a maximum at the graph. Now, one thing, again, almost getting English class here. For min and max, we say that the actual value is the y-coordinate, but then where it occurs is the x value, the x-coordinate. Okay, this comes into play a whole lot more with story problems and just talking about where and what the values might be. All right, so let's work on graphing. Now, this is in vertex form. So once we're in vertex form, it's actually really, really easy to graph. Our vertex, we just look, here's our h value, here's our k value. Now, remember, in our function, it was h minus. And so to get it, I'm sorry, x minus. So to get it to say x plus 1, this is really x minus negative 1. That means the x value is negative 1. Outside the parentheses, remember, we just think of it as normal, so we think of it as positive 9. Does the graph have a min or max? To do that, we're going to look right here at that negative. Because it's a negative, we know that it's going to open upside down U, so then that vertex right there is a maximum point. Okay, what is the max? Remember, that's the y value. Where does it occur? Right there. Now let's go ahead and graph that. So go -1 up 9. This goes back to sort of transformations and knowing our parent graphs. Remember, for a quadratic, usually we go over 1, up 1. And then remember, squareds, we go over 2, up 4. You could go over 3, up 9. Now, these are quadratics, so we've got a mirror image. The one thing you do have to worry about is right here, if it's stretched. We'll talk about that here in a second. But for this one, it's not. Now, I'm not going to go up 1. I'm actually going to go down 1 because I know the graph opens upside down. And then I'll go over 2 and down 4. Mirror image. That's going to give us 5 points. I feel pretty good about going ahead and graphing that right there. Okay. Next example, real similar. Vertex, again, we just look inside the parentheses, but we think opposite of what we originally see. Outside, we think normal. This is a positive 2, so it's going to open up. So that's a min. What is the value? Is y. Where does it occur? Is x. I'm going to put a vertex at 3, 1. Now, here's where the 2 comes into play. Remember, we went over 1, up 1 on our last graph. Over 2, up 4. Okay? But what happens is right here, this 2 is going to multiply our ups. Okay? Outside the parenthesis, that controls our stretching it up and down. So here, I'm going to multiply by 2, and I'm going to get 2. I'm going to multiply by 2 and get 8. So for my graph, I'm going to go over 1, up 2, mirror image, over 2, up 8. Oh, this all needs to be moved down 1, I'm sorry. So then over 1, up 2, and then there's our top point. Mirror image again, we'll talk a whole lot about that mirror image. And then just connect it, make your U. All right, so that's graphing from vertex form. Now, I'll be honest, sometimes we don't want to complete the square, right? Sometimes we just want to find straight from the vertex. The equation needs to be in that form, ax squared plus bx plus c. The x-coordinate of the vertex is negative b over 2a. You've seen this before, you've talked about this before. You're going to just say it over and over again that you're going to know this formula. All right, so negative b over 2a. All right, there's my a, there's my b. So the opposite of negative 6, that's going to be positive 6 over 2a. That's going to be 6 over 4, so 3 over 2. All right, now, I'm asked to find the vertex. That means I've got to find the x and the y value. So once we get here, we're just going to plug and chug. Now, I'll be honest, I would really rather you just use your calculator at this point in time. Type it in exactly like this, right? 2 parentheses, 3 divided by 2, parentheses squared, and then just keep going. Once you hit equals, you should get negative 1/2. That means my vertex is 3/2 and negative 1/2. Okay, example 4, we see the word maximum. So we know maximum refers to that vertex point. And it says, what is the maximum value? When we say what is the maximum value, that means we're finding the y value. So unfortunately, there's no shortcut to just jump straight to the y. We will find the x first. So again, there's my a, there's my b. And let's see, we're going to have negative 20 over negative 8, which is positive 5/2. And we've got to plug it in. Again, I'm okay if you use your calculator here. And you're just going to hit equals and get 22. Now, here's where you got to be really, really careful. Please make sure you only answer the correct part of it. It says, what is the maximum value? It's right there. It's 22. Okay, so in this one, if you give us other information, we will have to count it incorrect. Example 5, minimum. All right, so I know I'm talking vertex. I know it's going to open up. And then it says when. All right, when means we're looking for the x values. All right, so x equals, there's a, there's b. Let's see, the opposite of negative 7 is 7 over 2 times 1. There you go. That's it. Don't do any more work. If you plug it in, not only are you going to spend more time than you need to, but you are also not going to get full credit because you're not answering our question. If you look right below there are 3 more examples of finding the vertex. Again, those are included in other places, not in this video. The stored problems will split up and we'll do in a separate section. So that's actually going to be the end of section 3.6, quadratic functions.